Okay, question 11. So we have let f be the function defined by f of x equals the square root of the absolute value of x minus 2 for all x. Which of the following statements is true? And then we have a bunch of these statements. So the first thing I'm going to do here is just go ahead and graph out what this function should look like. So whenever I have x minus 2, if x equals 2, then y equals 0. So that is going to be kind of like my origin starting point. So if x equals 2, then y is going to be 0. And again, we cannot have any negative values. So what that essentially means is that anything that would be a negative value or a negative y value is now going to be positive. So what's going to happen is I'm going to have my square root function, but then it's going to be reflected on the other side here, right? So it should be a reflection. Now, if I zoom in on this point right here, so let me just kind of zoom in. If I zoom in super close, it is going to be incredibly sharp right here, because I go from, well, because it's just a straight reflection, right? And if it's a straight reflection, then it has to be perfect, and that's going to give us a sharp point at the end. So we know that if I have a sharp point, so I'll say sharp point, therefore not differentiable at sharp point. All right, so it's not differentiable. So anything that says it's differentiable is out. Now, E says x equals 2 is a vertical asymptote, and that is not true. Let's see here. The limit as x approaches 2 for f of x is not equal to 0. And no, that's not true. The limit as x approaches 2 for f of x, that does equal 0. That equals 0 because, look, if I approach from the left, I get 0, and if I approach from the right, I get 0. So that one is out. F is not continuous. No, it actually is continuous. There is a point there. And then finally, A, f is continuous, but not differentiable, and that's what we already talked about. So therefore, A is the correct answer. All right, guys, if you have any questions, feel free to comment below, and I'll see you in the next video.